Welcome Chemistry 30. This video deals with Unit 2, Section 15.1, what are solutions? And if you have a textbook, it's page 452 to 459. I'll be going through most of those pages, so if you don't have a textbook, that's fine. The objectives, define and provide an example of soluble, insoluble, solvation, solubility, saturated solution, unsaturated solution, and supersaturated solution. Describe the characteristics of solutions and identify the various types. Relate intermolecular forces in the process of, that should be solvation, not your salvation, and identify the factors affecting solubility. So, questions. What are the three states in which a solution can exist? We could have a solid solution, liquid solution, or a gas solution. And then from there we have different solvents and solutes which make up that solution. So if we look at the difference between solute, solvent, and solution, solute is the substance that you're dissolving, for example, salt. The solvent is the substance that is doing the dissolving, most of the time it's going to be water. And solution is that combination of solute and solvent. So for example, here we would have salt water as our solution if we dissolve salt in water. But of course, that's one type. There could be many different types here too. So a gas solution, for example, oxygen dissolved in all of the gases in air. That would be a gas dissolved in a gas. Liquid solutions, we could have acetic acid dissolved in water, and that gives us our vinegar, alcohol in water, etc. A solid dissolved in a solid. Different types of steel are actually made up of that. In the textbook, they have this table here, which gives you an example. You may wish to copy out a few of those. So we have a gas and a gas and a liquid, liquid and a liquid, solid and a liquid, and of course different liquid in the solid, also solid in the solid. So those are all examples of different types of solutions, more different ones that we may not look at exactly initially as being a solution. We tend to think of solids dissolved in liquids or liquids dissolved in liquids, but certainly there are more than that. Okay, back to the assignment here. Soluble and insoluble. Soluble means that the solute can dissolve in the solvent. For example, salt does dissolve in water, so that salt is said to be soluble in water. Whereas insoluble, a solute cannot dissolve in the solvent. For example, if we have oil in water, oil does not dissolve in water. So what properties make water a good solvent? The fact that it is polar, it has opposite charges on opposite ends. So if we assume the water molecule to be H2O, at the hydrogen end, it's positive. At the oxygen end, it is negative. Kind of looks like a Mickey Mouse head. And the process of solvation, the process in which solvent molecules, i.e. water, surround a solute and break it apart. And there's a good picture in the textbook, which we'll look at in a second. And kind of a little way of remembering that is that like dissolve like, polar dissolves polar. Okay, and if we look at the textbook there is a good picture of this happening right there. So the solvation, actually if you look up here, we can see the water molecule. We say that this is a Greek symbol here. Negative on the oxygen end, positive on the hydrogen end. So if we look in water when it's in salt water, or we have a piece of salt in water, you can see how this works. So the positive, if we imagine this cube here to be salt, the whiter blocks here are the positive sodium ions, the pink, or the green yellow ones here are the negative chloride ions. So if we take a look, the positive sodium are surrounded by the negative part of the water molecule. So in other words, this part of the water molecule is going to attract the positive sodiums, as you can see in this diagram, specifically this one right here. Okay, and vice versa for the chloride ions, they're negative, so the positive part of the water molecule is going to attract it. So again, the positive part is where the hydrogens are here, so they pull apart the negative part of the chlorides there. And then that bond between water and the salt is stronger than the forces holding the salt together. Okay? So in this question here, kind of just a summary of that picture. If you want, you could rerun the video, pause it, and make yours a little bit neater than mine, but that's what I'm trying to illustrate here. The chlorides are being pulled by the positive hydrogens, and they're surrounded by the water and held in water. Or the positive sodiums are pulled by the negative oxygen parts and surrounded. So that is the process of dissolving it. The salt doesn't disappear, it's simply pulled apart into ions. Salt and sugar are soluble, polar attraction between the salt and solvent. Oil, we don't have that polar attraction happening there, therefore it is insoluble. Water cannot pull it apart. Number 7, what must happen in order for solvation to be a possibility? The solute and solvent must come in contact with each other, of course, so that there can be that pulling effect. And of course, ways to increase the possibility of something being dissolved. These are things that we know with common everyday experience. Agitation, so if we're stirring the solid, stirring the sugar in the coffee, that increases contact time and the likeliness of water to pull it apart. Of course, hot coffee dissolves sugar much easier than cold coffee. So increased temperature, you're causing those molecules to move faster, hit harder. And also surface area. So there we can look at, if we increase the surface area, what we're doing is really breaking something into smaller pieces, i.e. powdered sugar versus a sugar cubed. So the powdered sugar would dissolve much quicker.
Where would you